Oh, our title? Yeah, we have plans to come up with a great title at the last.
Okay.
I can also introduce myself if you want. I actually sort of self-introduced.
Thanks, yeah.
Yeah. Okay. Hi, everyone. Welcome back. On behalf of the Russell Sage Foundation and Princeton University, it's my pleasure to welcome you here to Deborah Estrin's talk, and it's my pleasure also to welcome all of you on the live stream. Deborah Estrin is a professor of computer science at Cornell Tech, which is a particularly exciting place. I got a chance to spend a year there, and one of the things we've talked about at the Institute a lot is combining ideas from social science and data science, and I think Cornell Tech is one of the most exciting places where that kind of thing is happening a lot. And actually, when I talked to Deborah about this and I was inviting her, she initially said, "No, I'm not a computational social scientist. I don't think you should invite me." And I said, "No, I think you are a computational social scientist. And just because you don't think you are, that's even more reason for you to come. So you could meet this whole new community that's going to be really excited about what you're doing." And, we've heard a lot about big data, and I think Deborah's work and her group's work about small data is very exciting complement to that, particularly thinking about when people think about digital trace data, they often think about these huge aggregations of it sitting on the servers of companies, but now it's increasingly possible for people to access these for themselves. And so if you can create some way that people want to do this, you can provide services to these people that are very useful and do a lot of interesting research. So we've talked a lot about Pasteur's quadrant, combining stuff that's motivated by use and that seeks fundamental understanding. And Deborah's work is really special in that it's very much in that Pasteur's quadrant. So we're going to see a lot of cool stuff. And welcome Deborah. And before we get to hear Deborah's talk, she would like I could introduce all of you. But I think it would be better for you all to introduce yourself, so you could just say your name and a little bit about where you're coming from. That will help Deborah.
Institution and discipline.
Institution and discipline, and that will then, when we have a discussion or you have a question, that will make it a little bit easier. So, Charlotte, do you want to start?
Sure. Charlotte Wood in sociology at Harvard.
And Yo-Yo Chen in demography at Princeton.
Mike Yeomans, I'm a postdoctoral fellow at the Harvard Kennedy School in behavioral science.
Isewa Juanu, I'm a demographer. I come from the University of Cape Town. From the University of Cape Town.
I'm Ethan. I teach politics at GW.
I'm a PhD student in sociology, Yale student. Anyway, I'm Hiro. I'm a PhD student in sociology, Yale University, and also the Institute of Network Science.
I'm Anna. I'm a postdoc in the School of Computer Science at Princeton.
Antti Krishna. I'm with RTI International. I'm a survey methodologist and also adjunct faculty at the University of Nebraska in Lincoln.
I'm Abdullah. I'm a PhD student at MIT in computational science and engineering and a research assistant at the MIT Media Lab.
I'm Moritz. I'm at the University of Zurich and in communication research.
I'm Anjali. I'm a PhD student in organizational behavior at Stanford.
I'm Molly. I'm a postdoc from psychology at the University of Chicago.
I'm Joshua. I'm a PhD student in communication at the University of Pennsylvania with the Network Dynamics group.
I'm Maria Rodriguez. I'm an assistant professor at the Silberman School of Social Work at CUNY Hunter.
I'm Tong Wang. I'm an assistant professor at the business school in University of Iowa. I work on computer science.
I'm Connor, a PhD student in sociology at the University of Washington.
I'm Rudy. I'm a demographer at the University of Oxford.
I'm Allie. I'm a computer scientist at the University of Colorado Boulder.
Hi, I'm Adana. I'm in sociology, postdoc at Brown.
Kevin, I'm in sociology. I'm a postdoc at Bocconi.
At
Bocconi. Martin Elmarca, Aalto University, Helsinki, Computer Science and Political Science.
I'm Ian. I'm at UCLA and I'm in sociology.
Hi, I'm Rochelle Sherman. I'm in political science and a postdoc at Stanford.
I'm Lisa Erhale. I'm political science postdoc at Princeton.
Hi, I'm Kat. I'm a graduate student at Northwestern in sociology.
I'm Taylor, PhD student in sociology at Duke.
I'm Jeff. I'm a PhD student in political science at Columbia.
So, first of all, who am I? I made this slide some time ago, and so now I sort of find it useful. That's the problem once you create a slide. And this whole n equals me. Do I need this thing? I need it for the live stream? I'm really loud, and generally people want to give me muting devices. Not just so this n equal me thing, I'll come back to it. It's a little bit of a meme that came from when I did this TED-Med talk. But this is just my background going sort of column by column. Grew up in LA. Some of you might or might not recognize the person in the upper left corner. Anyone know who that is? No? Wow, I'm old. There we go. Yeah, Ms. Magazine, that's right. So, you know, I graduated from high school in '77, and lots of things were happening then. Didn't know that it was going to not be monotonic, but went to Berkeley as an undergrad, which is sort of what somebody who had that affiliation attended to do. I studied electrical engineering, computer science at Berkeley. Went off to MIT for grad school, and I was just telling, who did I tell this to? One of the students who I met with, that when I went to MIT, I thought I wanted to do something with more context to building technology. And I went into something called the Technology Policy Program. I don't actually usually mention this. It's not on my CV or my bio. And then I went running back to more straight technology stuff and did my PhD in the lab for computer science. Because I'm more of a builder, engineer, activist than I am a scholar or an academic. Even though I've been an academic now for a really long time, because I went to, in 1985, I finished my PhD, started it in January '86 at USC, and at ISI, which is Information Science Institute, where the internet, lots of components of the internet were being built and stood up. So the first domain name server. What's wrong?
No, keep going.
Okay.
Just
Okay. The first domain name server, you all know what DNS is, right? So the DNS was designed by Paul Maka-Petras, who worked at UC Irvine and then ISI, and the first domain name server was there in this building in Marina Del Rey. And all the other components of all the algorithms and protocols that make the internet work, they weren't all done at ISI, but there was this large distributed community that organized itself through the IETF, an interesting process in and of itself. And I spent my really formative years. I came out of a group that did internet stuff, and I went on and really spent a bulk of time doing internet protocol development. And that shapes how I think about things. And that's the reason I am bothering you through this thing, because what I do and the approach I take to things is just pulls a lot of context of whatever I did before. So in particular, I don't understand why everything isn't modular with, you know, well-documented interfaces, and so that you can have things evolve and deal with heterogeneity now and later. And I'll come back to that at different times during the course of the talk. Around the later part of the 90s, the internet suddenly went from things where nobody knew what a domain name server was to seeing URLs on the side of a bus, which I realize means nothing to you guys, but that was just amazing the first time I saw URLs on the side of a bus. Because when I started teaching networking, I had to actually argue with my colleagues why I was teaching TCP/IP and the Internet Protocol Suite and not this OSI 7-layer reference model, something or other that was being proposed out of Europe. Like, why was this artifact, this particular set of rules of doing something, why was it important? Because it was just not recognized how important it was. It's not that I recognized how important it was, it's just that I grew up with it professionally, and so, and it was growing in importance. It seemed like a good concrete thing to teach. But when you got to the later 90s, suddenly it wasn't just that internet stuff was being recognized, it was now critically important, which meant it was very much harder to innovate. So I worked on routing protocols and things like that, something called multicast routing, and you could work really hard and come out with something and work it all the way through the IETF and come up with a standard with the gazillion edge cases to make the thing actually work, but then no one deployed it at the time because it was too risky. And there turned out to be a whole bunch of bandwidth at the time available. And sort of, I'm very pragmatic. I have huge respect for theoreticians and sort of real scientists. I'm just not one. I just am somebody who tries to build or do things, and I need shorter time frame. I wish I was different. It's not that I say this is the way to be. It just is the way I was born. So the reason I'm telling you this is that at that point, it's sort of, okay, I can't do routing protocols anymore because I can write papers about them, but no one's going to deploy them. So I had to look for something else that I thought I could do something useful in. And so I started working in this area that, in some sense, is now known as Internet of Things, but was known as wireless sensor networks or distributed sensing. And why this story is relevant here into this group is that before then, I was a networking person. And a networking person from a protocol, not your types of networks, from a routers and packets and things like that. And the whole point was to be application agnostic. You had nice modularity, you were building a network, and actually that's the amazing power of the internet, right? It's this narrow waist, everyone implements IP, but all kinds of stuff happened on top of it that nobody ever anticipated, and it could all reuse the infrastructure that was built of the internet, right? The web could happen because the internet was underneath it, connecting all those machines on which you could go and implement HTTP, and you didn't have to change anything underneath it. So that all the religion, the power of the internet was this application agnostic. And I went and started working on distributed sensing, and suddenly that didn't work. Because if you're working on sensing and you're a technologist, not a theoretician, you need to know what you're sensing for. Are you measuring temperature to, adjust the climate in a building, or are you measuring temperature to understand ecosystem dynamics to support ecologists who are trying to come up with models of climate change or something? It really matters. So that transition to that second column broke my nice, clear boundary. We used to run network, the main academic conferences in networking. Every once in a while, we would admit some application papers, almost like a kind of affirmative action, right? We would have some token of application papers, but application, that was not a good thing to be. So when we crossed over into that, suddenly now I was dealing with data, and we were building systems that dealt with data, and started working with folks who actually knew how to deal with data, unlike most computer science students at that time. So there was a while I was walking around saying that if I was stuck on a desert island and I only got one PhD student, because you're a faculty member, the only thing you absolutely cannot live without is a PhD student, right? So if I only got one PhD student, I was going to take one from STAT and not from CS, because there was not much training necessarily around dealing with data at that time. So things have changed rather rapidly. Mark Hansen, one of my colleagues, I don't know, somebody here is from Columbia. If you haven't reached out and met Mark Hansen because you're at Columbia, you should. And even if you're not at Columbia, you should. So he was in statistics at UCLA at the time. So I crossed that barrier, and I've been working with folks in purpose-driven, application motivated stuff. And it's not great because it's less general. You can't create the internet that on top of which anything can happen, right? There are compromises in going and doing that. I don't necessarily think about whether I should do this. That's just a boundary cross. And so we started doing a lot of distributed sensing, and then around 2005 is when programmable mobile phones, not Androids and iPhones, that was a couple years later, but before then were the Nokia phones that were programmable, had lots of radios in them, and you could start programming them to do things. And Nokia launched Sensor Planet and offered to send hundreds of mobile phones to faculty, to academics who would make proposals. And they even said we'd have activated SIM cards in them. Like, they're not just the devices, they'll be online because we're going to do some virtual network thing. And so now, like any good opportunistic academic, I had to come up with something I was going to do with hundreds of mobile phones. And suddenly I had more mobile phones than motes and actual distributed sensors. So these became my sensors. And once these are the sensors, those sensors are on people. And it's not just about monitoring things in the environment, it also became about monitoring them. So I've just stumbled in, that's the extent to which I was absolutely right when I said I'm not a computational social science. I'm a technologist who has followed what seems compelling and useful to do. And that sort of ended me up in the context of health. Okay. So I will talk a fair amount about health, although this isn't, I hope that that you can identify some places where this can relate to things, particularly a lot of the things around health are around behavior, and you can see ways in which this can be applicable to things beyond health as well. So in end of 2012, 2013, I was working on this TED-Med talk that I was asked to give, and I have never worked on anything so hard in my life, particularly as it comes down to 11 minutes, right? The amount of work put into each of those minutes was absurd. Mostly I was mortified of screwing it up. When I sat down from giving the talk, I got a text message from my son saying, "You didn't screw it up." So, he had tried to calm me down the week before by telling me, "Don't worry, Mom. If you mess it up, they actually retape it before they put it live, before they put it on the web for archival use." Anyway, that's where the term small data, the use of the term small data as opposed to micro data, or a bunch of other terms that I actually think are better, was because they have handlers, particularly, I guess, for people might be. There are some people who don't need handlers. I needed a handler. And some really talented people who helped me craft a story down into those 11 minutes, and they wanted this attitude-ish thing of small data, okay? All I mean by small data, I don't mean that big data isn't important. Big data is hugely important, and it is really a bigger part of the story. So if you think about it in terms of health, big data science is looking across electronic medical records, claims data, patient communications across large populations, and studying it to understand and be able to build predictive models of X, Y, or Z conditions so that you can treat it earlier and treat it better. Now, another huge aspect of big data science is all the omics, right? There, you have to do big data because there is no functional understanding of the genome. They can't reason about anything about it from first principles, so it all has to come through empirically what relates to what. And it's not just genomics, it's, you know, it's a microbiome and epigenomics and all kinds of things. Incredibly important, hugely interesting, just doesn't have to be what I do or am competent to do. So where this comes in is that there's all kinds of data about individuals over time that can be relevant to their health and their care. And so small data is just not large n, it's small n, maybe just n equals 1, over time, but multiple, generally multiple data streams in that space. And so at some level, can we use that small data to help fill the gap with what patients are born with, which is still what most of the genomic story is about, and what they actually suffer from. And now with microbiome and other things, there are things in this omics space that are clearly not just about what you're born with, but they tell only a part of the story. And so to fill in that story, that's where this individual data over time and that focus on doing that well and enabling that. So those same data that are up in that cloud are used by, in the big data sense, by those entities who happen to have access to across their client base or their patient base. And they can look at an individual in their database over time. But then the point is that there's, in some sense, secondary use of those data streams for another purpose that might be of no interest to that particular vendor and might really need to be combined with other data sources. Now, I will talk about data streams that aren't just secondary use. And I'll call that also sort of a part of this, if you will, this longitudinal data stream about an individual. So let me just add a little more context about because as I described to you, it matters how it's being used. So I'm not necessarily doing this to discover new science. I'm sure we will discover new science. But it's hard when you start with this model of sort of N of 1 to set out and say you're doing it for science, because you're doing it with N of 1. So you're not going to be able to draw grand conclusions about other things. It's about this individual. Now, look, if I were, not if I were God, right? If I were Google, I would do both, right? I would have access to so much detail I could do it all at once, but I'm not. So I recognized at some point in here, I just need to do things that scale down, that I can actually do, and that are useful to do, that I don't feel just sort of made irrelevant by, you know, Google and Facebook and such. That's a battle in this space, right? How do we find the place where we contribute to the world when we're not in those, you know, embedded in those data sources? Okay, a different existential problem. So these are the data loops that I think about that are relevant when I'm thinking about what data do we need and how are we going to process it. I learned in the context of that distributed sensing sensor network, I better know what I'm using my data for, or I won't really know what work to do with that data. It's not just like more data the better, any data is good. When you're trying to build something, not particularly true. So these three sort of feedback loops of health, the one we usually think about is clinical care. So everything I say, think about it as post-diagnosis. Nothing I'm trying to do, or I'm not talking about here, is about diagnosing individuals. Because diagnosing individuals, you've got to do that big N thing in order to figure out diagnosis. So I'm not interested in diagnosis. I don't mean it's not interesting, I'm not interested in diagnosis, okay? I'm interested in helping with the problem after people are diagnosed, because I'm fundamentally and pathologically pragmatic. So if I have no idea what to do about a problem, I tell them I'm not interested and I don't try to work on it because I have no idea what to do. So post-diagnosis, somebody is diagnosed with multiple sclerosis, or rheumatoid arthritis, or migraines, or GI disorders, or depression, or anxiety, or a whole host of things that are in this spectrum of chronic disease. And they get diagnosed, and then they're put on some treatment plan. Maybe it's lower back pain. And they're put on a treatment plan, and because we are decades away from the precision medicine thing being deterministically applicable to know exactly how much of which medicine I should give you in order to address the problem, clinical care is empirical. You put somebody on a medication as low dose as possible, you see how they do, you monitor the symptoms and the side effects. If the symptoms are not adequately addressed and the side effects are not too high, you increase their dose. It's called titration. Okay? And then if one drug isn't working, you try piling on another. Okay? And that's how people end up with, I don't know how many of you know people who are older and the number of medications that they take by the time, some of which it turns out have no role anymore, but in any case, it's very complicated. And right now, the data in that feedback loop is in some cases, you're trying to control somebody's blood pressure. Guess what? You come in and you measure their blood pressure. Guess what? Even then, that's problematic because it's a single point measurement when they come into the office. They might have white coat syndrome and their blood pressure might be elevated because they're there and worried about whether you can tell that they haven't followed any of the dietary suggestions that you gave them, or that they actually didn't refill their medication over the last 6 months because of a copay issue or just not getting to it or what have you. So that single point of measurement in the clinician's office is largely how things happen when you actually have a clinical measurement, when you can measure somebody's blood pressure. But what do you do for depression and anxiety? What do you do for pain? There is no objective measure now, and for the decades of the horizon in which I design anything, there is no measure to say how much pain somebody is experiencing, because we also experience, we have different pain tolerance. So it happens through self-report. And that self-report is at that moment when they come in, and it's retrospective self-report. And that would be fine if we couldn't do much better. So what I'll be talking to you about is where can we do better, because our data that is captured now much more frequently than when we go into the clinician's office has in it the opportunity to infer things about the patient's condition and their response to care. And then the same thing goes for self-care. So you can be given a medication that says take as needed. All these inflammatory conditions and autoimmune conditions that have been growing in prevalence, they are not cyclical. They have cycles that don't look cyclical in any predictive way. They have flares and remissions. And we don't, in many cases, understand what the trigger is or if there is an external trigger. And so people are told, when you're starting to experience a flare, do X, Y, and Z. Certainly, the opioid crisis we're in is in part associated with the take painkillers as needed problem. So helping people close their own feedback loops as well. Not a trivial thing, I will admit. And then finally, but not finally, but very importantly, is just research evidence. So I'm sure you've encountered something and you wanted to know, does X influence Y, or the dietary suggestions that people make, or, that sections in, not just in Whole Foods, but in every CVS and Walgreens of supplements. People buy things and they take them because there's some belief that something, ginkgo biloba or whatever it is, has some effect. And in many contexts, we just don't know. And if you ask doctors, they will say there is no evidence, and there is no evidence doesn't mean no. It just means there's no evidence. It means that it hasn't been worth anyone's time to go through that arduous process of doing a randomized controlled trial to figure it out. Moreover, this whole way in which we generate evidence, which is around randomized controlled trials, is itself leaves room for improvement, and the role of, if you will, this small data. And this is a slide I stole from my colleague Ida Sim at UCSF, Richard Kravitz at UC Davis. He was one of the first people who wrote about specific N of 1 trials in clinical, N of 1 in clinical care. So Ida tells this story. She's a real doctor, an MD. And she tells a story that, she reads the latest literature, the results of the clinical trials. There's some new antacid medication or something else, migraine, whatever it is. And the drug was approved in 75% of the people in the trial. This new drug was more effective than this over-the-counter thing that preceded it. That's, 1/100th the cost or whatever it is. And independent of cost, this is more effective. That's what she would prescribe to her patients. But the truth is, when somebody's sitting in front of her, she doesn't know whether they fit into the 75% or the 25%. And since it's not surgery or chemotherapy or something that is irreversible, and it's something that they're going to be taking sort of forever, or should, so high blood pressure, when you have high blood pressure, it actually doesn't go away. You don't take high blood pressure medication and then it goes away. If you're pre-diabetic, you can still turn it around. Once you're diabetic, very difficult to turn that around. So in many contexts, you're prescribing a medication that is going to be taken for a very long time. Why not take a few weeks or whatever is the time scale of effect and try them on one thing with a washout period and try them on the other and do the N of 1 for them and find out what works for them. It's worth that investment given the length of time they're going to be taking this thing. And so the idea is now, because people are walking around instrumented and interacting with it, that this notion of bringing N of 1 and to not just evidence generally, but evidence for that individual of what's working for them. So I'm talking a lot about chronic disease because it really does matter. So 7 of 10 deaths, 86% of US healthcare costs are associated with chronic disease. And there was a really, his work is always unbelievably elegant and articulate. Atul Gawande wrote a piece in the New Yorker in January of this year on the heroism of incremental care. And how, you know, we think of the surgeons and the people who do emergency medicine and trauma care as the heroes that save lives. But so many people over time, it's really the people who, if you think about migraine sufferers and others, people who, through incremental care, are able to find what works for that individual. And so this is now how I think about a lot of what we do. I just point back to his work. And you know, just read this the second quote, that this capacity to monitor the body and the brain for signs of future breakdown and correct the course along the way is that holy grail here. Okay, so what data sources am I talking about? And so I want to take some slides to talk about those data sources. From the phone. Oh my God, I've been saying this for 10 years. And so it's still the case. The richest source of data, and I'll talk about each of these sort of sequentially. Before I do that, I want to say, I indicated this before, I'm talking largely, starting out, measuring and monitoring established symptoms, side effects, and behaviors. I'm not looking to discover some, wow, surprising, you had no idea that this could be a measure for that. That will all happen, but you can't really do that until you do the large N stuff. And there's value in doing the small N stuff, because there are individuals out there, and now Atul Gawande has even recognized it, right? There are individuals out there who need incremental care based on how they're doing in response. So, and let's start with a lot of things that clinicians know. They know, these are the questions they ask. You have rheumatoid arthritis? They ask you when you come in, you know, how long does it take you to get out of the house in the morning? Because it's a functional way of asking you about morning stiffness. You have IBD or IBS, a GI disorder? They ask you the same question. How long does it take you to get out of the house in the morning where you feel safe enough to not be caught with urgency away from your, you know, your home bathroom? Depression. Established symptoms, you know, what time are you missing work? How much time are you spending out of the house on the weekends? So there are these established questions, and all the things I'm going to be talking about are initially ways of using this as a way, for the first time, of being able to measure something, if not continuously, far more frequently than just when you come into the clinician's office. So still the most return on investment, the most information-laden information is just your activity location trace from mobile phone. And so our phones are, for the most part, unless you have a certain kind of hygiene, other words you can use, a certain kind, if you're really vigilant about turning off location services and things like that, yeah, there's a small segment of the population that both has smartphones and is very vigilant and is not generating these traces. But for the most part, lots of people have smartphones. Most of them have them because they use them for navigation, Google Maps, all kinds of other services, and they are then therefore. Am I worrying about this?
No.
Just trying to talk to me. Okay.
Ignore that.
Okay. So that GeoTrace is the source of information of your diurnal and your social rhythms. So you don't have to ask somebody who has rheumatoid arthritis if that discomfort in the morning necessarily is causing them to get out of the house later or not, because you could look at that number that is derived from their GeoTraces. You don't have to ask somebody if they're able to walk faster than they were. Are they healing from their lower back pain? So if you put somebody into some kind of physical therapy to deal with lower back disorder, it takes a while. You can do surgery, which happens quickly and many, many cases doesn't work. You can do all kinds of, all kinds of things that surgeons and device manufacturers have come up with to try to deal with lower back disorder. And in most cases, there is data to the effect that it's certain exercises and walking and not being too sedentary, etc., is what really works, but it takes a long time. So but not for everybody. So if you start somebody on a treatment for lower back pain, and they come in 2 months later, and you want to know, the doctor wants to know, are you 15% better or worse? How the hell do you know if you're in 15% less pain, if you're walking 15% more? That isn't something reportable, but it's completely knowable. So that mobility index for a whole range of symptoms, yes?
Is that something that's created automatically by the phone, or people have to do extra stuff? So some of the sensor stuff is automatic.
Yeah.
People don't have to do anything. Some you have to.
Who's you?
Me. Like, let's say I wanted to do this.
Yeah.
Could you just take my phone and do this?
Are
or
you
do I
the
need to
researcher or
turn
are you
someone
the
out?
individual
I'm a
participant?
patient.
All of this is just a matter of some software being downloaded on the phone and running in the background, and in fact, you don't even, it's happening to you from that ethical P-word issue. This is out of your control for the most part, and this is all happening all the time. So the answer is this,
yes.
Nothing on the part of the patient. There's nothing you need to do intentionally.
But if I was a patient and came to you for the first time and I didn't have the app yet, and you couldn't get ready.
Okay, so I'll jump ahead because any of you have looked at Google Takeout. So the one, yay! So the one I've never made that horrible pun before. The one takeaway I would like to suggest is what Google Takeout now gives you the opportunity to see. So we're just starting the work. I just mentioned it a little bit later. But it's been so frustrating to sort of be in this space, particularly as all this big data stuff that you guys do, right? And you can't get a PhD, like PhD students are not that interested in this kind of work because they publish and they drive that thing by dealing with big data sets. And there are no big, small data sets for the most part. But now we have Google Takeout with people having been online and more for this decade. What is Google Takeout? You go to your Google account, you go to Google Takeout, and you can export your historical data, which includes location and searches. You know it's going to be noisy and variable granularity, and it's not going to be as granular in those years when you weren't really using Google Maps as it is now. But for the first time, we can have somebody's baseline. Not for everybody, right? It's not as prevalent as just having a mobile phone. But we can start doing a fair amount of that because we have retrospective data with Google Takeout. So how do we get to it? You need to get people, just like they can get their genome and give you their data, they can go and get their patient record and give you your data. We now have our first IRBs that include that people will go to Takeout and download their data and let us do an analysis over it under IRB and all of that. So pretty exciting because now things don't all have to be perspective. And yes, troubling, if that's why you're shaking your head.
No, it's wild.
Oh, okay.
Could you give us a little more sense of what the data might actually look like that are on Takeout, like you mentioned, like logins?
So location as it's known, and it depends how much you use certain apps that are registering your location with Google and Google, and you can be somehow not seen by Google, and so it's variable and it's messy, and you can't count on it being the same. Okay, location.
But could I say could I take a good, if I binned it by day, could I take a good guess of where someone is by day based on the data?
By day?
Yeah.
Yeah.
Like assuming everyone used Google
Yeah.
Maps to go somewhere else.
Yeah. Yes.
Right?
Yes.
That's pretty amazing.
Yes. Search history. Okay. Now you can also get to, and you don't have to do this through Takeout. You can get to this through an API. You can get to Gmail. So, right, do any of you use TripIt? Right? So how do you use TripIt? Do you forward your email or do you let it, you didn't do that thing of let it go directly to your Gmail. But a lot of people obviously do because that's one of the things you can do. So TripIt, when you get an airplane receipt or a train receipt or a hotel receipt or a car receipt, doesn't matter what it is, you get a receipt, you just say forward to plans at TripIt and you have an account, it knows how to parse it, you don't need data standards, it's a small enough context that it can figure it out, and it builds a beautiful itinerary, right? Nobody needs anybody to do their travel planning for them anymore because it's just all there in TripIt. You can keep track of everything. Makes a nice little itinerary. One of the things TripIt offers you, it says, so that you don't have to worry about remembering to forward your reservations, we will just access them directly out of Gmail. Give us permission to use Gmail API through OAuth on your behalf. And there are all kinds of other services that do this as well. And right now, the granularity of that access is basically everything. As opposed to saying only, Gmail should have an API that says only give access to my receipts, but it doesn't. I expect that will change. Okay.
Can I sneak just one more question? Are
Yeah.
you going to talk a lot more about takeout or not? Not at all.
I'll just talk a little bit. I don't care. I'll just skip it when I get there.
Just because I'm so
This is much
intrigued,
better.
because we've had a lot of discussion around IRB and accessing data
Yes.
and stuff. Could you tell us just a little bit about the process? Like, is there
I'd be happy to, and also I'd be happy to, I will, not instead of, I will send you what we wrote up in our IRB. I have to say, I am astounded with how wonderful Cornell's IRB is. Fast, responsive, and it's not that they're just not paying attention. Like, that's troubling to me when an IRB is so fast and responsive, but they're paying no attention. So, anyway, but I'll be happy to show it to you. It's just like anything else, any other intimate data you get from people when you bring them in and do, any kind of experiment, you treat the data securely. It's only available to certain people. You explain to them what you're going to do with it. You explain to them when you're going to throw it away. And some people say no, because you've explained to them the risks associated with it.
Can you request like just the location data, not the service
Oh, of course.
data through the
Absolutely.
API? Cool.
Absolutely.
Fantastic.
Yeah.
Wow.
And I know I haven't done this on lots of people yet. I am always doing what is not something that's recommended for anybody of your generation, right? I always talk about the thing that we're just in the middle of, because that's what I happen to be interested in. That's not what you really should do. But so this is, I'm not modeling correctly for you with that regard. But I know it's going to be a mess, right? And so what we're going to have to do in order to pull useful signals out of it. Let me just say a few other things. So some of this even even things like this diurnal history. So health rhythms, by the way, I'm an advisor to Tanzim. 1 second. Let me finish this sentence and then I'll take a question. Is being built into people who are developing products for particular conditions. So Health Rhythms is a startup, my colleague Tanzim Chowdhury out of Cornell and Ithaca, and they use diurnal patterns and things like that to build a tool to help people to manage a bipolar diagnosis, and they also do it in other behavioral health conditions, where one of the ways of helping people cope with it is to maintain a more stable social rhythm. That's been pre-electronics. That was an established, validated way of helping people cope, maintain consistent, sleep rhythms, eat rhythms, work rhythms, and so forth. And they would give you diaries and paper-based things to do, and they put that onto a mobile phone, and they auto-populate with some of these diurnal rhythms. So while some of this stuff is, not validated, we're just starting it, at the same time, some of this stuff has been built in a very specific context and tested in individuals. Yes?
Sorry, taking notes. Do you have an approximate idea of what the consent rates are to such requests?
No. Don't know yet. They're not horrible, but the numbers are so small that it's hard to tell. When we had a lower back pain study we did, not with Google Takeout, but just with a system that would go and we had people run Moves. Do you guys know Moves? It's an app that came out, nice app, was then, we decided, oh great, now we don't have to do this app that monitors passive data collection, we can just go and use it. Because it's a pain to maintain this stuff and stay up to date every time the models of the phone change and all of that. So we went to use Moves, and then Facebook bought Moves. And so then from our IRB's perspective and such, we were requiring people, because if you use Moves, you are sharing your location traces with Facebook necessarily. Anyway, when we went to do this back pain study, we say people would use Moves. Some, maybe 10% didn't want that. But something that we changed is that they didn't want us to maintain the place level information that Moves actually has, but they were okay with us maintaining time left the house in the morning, hours spent out of the house. So that was again a small number, but I was delighted. Right? This is a context in which I'm really happy when people actually show enough discrimination and thought to say no to these things. Okay. Activity data, this thing which I'm only wearing because it's a very small watch and most of the wearables are too big for a, relatively diminutive female's arm. But accelerometry step counting, which just represents how physically non-sedentary you are, is finally in clinical trials. So you don't need this when most of your movement is out of the house and you have one of these on you, but if you think about older populations or more sedentary populations who are home more, this no longer represents whether you're becoming more sedentary, and using wearables in that context makes a lot of sense. Okay, so location data, underused, very valuable, yes?
This is like just a technical question, but I find that, so I wear a Fitbit and I also carry my iPhone around everywhere.
Yeah.
But I find that there's never consistency between the counts.
Yeah, it doesn't matter.
Okay.
What
So
matters,
how do you deal
most
with
of
that?
the stuff, because I said, first of all, that I'm not trying to do diagnosis, and second of all, that it's about titration, the incremental care of an individual, what matters is that they track whether you're doing more or less.
So the trend matters.
The trend is all that, another way of saying it is, you're absolutely right.
Yeah.
And that's why the initial use of it is all about trends. But actually, most of what's relevant is, in these contexts, is trends anyway. And it's really important to, and that's why it's great that, otherwise you need to get somebody's baseline. In all these things that we do, like the lower back pain study or other things, you just measure to get the person's baseline. And then you intervene or you start, differentiating. But you have to have the person's baseline, which is dependent on their devices and who they are. Yep.
I don't know if this is a question for you or for Reedy, but shouldn't at least the trends match each other?
The trends should match.
Which they generally do. It's just that I find that, what I find is they never agree with each other.
Nah.
But if I did walk much more, both of them would
Yeah,
pick it up.
which is all that matters. And then there's, one or the other you might wear at different times, right? I do sometimes leave the house without this. It's really not essential. I never leave the house without this. I walk around the house if I happen to have it on with this on when I don't have this on me. So there are reasons why, even if they were calibrated, they wouldn't actually match. But the trends match. And it'll get better. It's so far from being the gating problem. Yes?
So just a follow-up question. So your concern, so since you're just so interested in individuals, right, and just looking at individual trajectories and sort of thinking of the data set as just generated by one individual, can you ever see this kind of research allowing for between individual comparisons?
Of course.
Even when there are these measurement or calibration problems?
Yeah, it'll get so much better. It'll be easier. Of course it will be. Because those things will get better. They'll go away. Even, look, the thing that says that you took a step is a classifier that runs over triaxial accelerometry data. And that model was created by actually measuring, people walking and with some ground truth. So those classifiers get better and better. That doesn't, at least in simple sensors like that doesn't worry me so much. And even there, the trends will matter more than the absolute, I don't want to say more. That there, in many contexts, the trends are very telling and useful. Trends across individuals, not necessarily absolute values. If you want to say, how does X affect this behavior, the behavior is a trend, not an absolute value. And you're going to look across a population to see how X affects that, whether you allow people to smoke outside the door of a building, or not. So there are these things that we can measure that also doesn't matter. It's not the absolute value that matters. There are others that do. Lots of things to do before them. And it's an important question because you should know what the measurement can and can't do and use it for what it can. Now, if you're an opportunist like me, I'm a technologist. So I go find collaborators for things for which the measurement works. But if you're actually a domain expert social scientist, you need to study what's important in your field, and the measurement might or might not work for you. So, yes. this Internet of Things label, which I just am not crazy about, but it's the term, so I use it. Really interesting in this space is the voice agents, right? And I didn't think they were interesting until it appeared that people really like to use them, and yes, they are interesting. So this, little hockey puck looking thing, I don't know how many of you have. Cool. And I don't really like talking to things. I don't like talking to people. So, I'd be surprised given the rate at which I'm talking, but it's not my thing so much. So anyway, but this is really interesting because yes, it's going to be another source of small data. How somebody talks, both the acoustics at the signal level and at the language level, is a very rich source of data. It has not been used extensively yet in any way from this, but I just want to put it out there as really interesting. And I find it particularly, look, we have voice agents on our phones. What is the big deal with this sort of denatured phone, right? That can do so much less than what a phone can do. It's interesting because, it's interesting to me because there's a population that I've wanted to be able to work with that's clearly important and relevant to chronic disease and all that, and that's the aged or the aging and people who didn't grow up as digital natives, right? So I've been using email since 1977. So that's why I don't like talking to people, because it influenced me so early that I had this safe asynchronous communication, even with my parents, who were also on email in 1977. How did I get off on that tangent? Okay, so so I think there's been quite some, both anecdotal and more than anecdotal evidence that speaking to an object through that standard interface of speech can be more comfortable for somebody who isn't a digital native. Now for some, it's just psychologically too weird. But we've had voice menus and things like that. We call in to buy something or reservations or to complain about something, and people are pretty used to these voice menu systems, right? And so the opportunity for this to be a piece of technology in somebody's home, not just for the people who are the latest gadget buyers, but because it's a comfortable interface for them, I think is quite interesting. And Amazon and others invested in consumerization of this because it will help them sell things, and so that's really another opportunity to be take advantage of. So it is not, today these devices are not listening, they're not recording all the time. You can explicitly mute them, and if you mute them, they really do not transmit sound signals, right? But mostly they're not muted because then they're not particularly useful, right? They are listening for a keyword and so here we design apps. On Alexa, you design skills. It's like your Alexa app, and you can program it. You can have a skill that listens for your keyword, okay? But just like with the original Google Glass, the OK Google, is that already like, even you guys are just before the Google Glass thing, wow. Okay, anyway, there was a time with that Google Glass thing that you said, OK Google, to try to get its attention. This, you say Alexa. I'll get to you in 1 second. And there are some useful skills out there that commercial companies are using this more and more, and HealthTap is one of them. An interesting one in the health space, yes?
I'm just wondering, has Amazon made any of that data available? And in general, like what, so Google Takeout is awesome, but what about the availability of some of this other data?
Okay, so first of all, if you implement a skill, you get your data.
Okay.
Right? Just like if you do an app, right, the app data goes to your server and you get it. It's part of, so you're a United Health Group, you're whoever it is, you can implement a skill and you get your data, it's your app. Now, Amazon is getting that data too. I have not, I wouldn't be surprised if somebody is like the early John Kleinberg is to Facebook, somebody is to Amazon, but I don't know who that is yet. So if you want to try to go and do that, then, carry me on your, coattails so that, but it's really interesting. And I don't know about the personal data APIs either. That I would like to try to figure out how to make that case, but no idea. And then, Google Home, maybe because Google is good at that, if Google Home ever actually takes off, then you could get it, the same kind of device, it just, is white instead of black. Okay, I am seriously running out of time. Okay, now, those are things that are techie. But there's also stuff that we have done, again, just out of pragmatism, which is, like, you cannot talk about this as a computer scientist because this is just there's no tech in this almost whatsoever, but it's really quite useful, which is just, sometimes you need to ask people things. And asking people things is relevant, even if it's not consistent with what you measure, right? What people think they felt, and then there are things that we just can't, we don't have access to enough sentiment analysis, enough other things to know how people feel, and we certainly don't have access. You want to ask them how they thought they felt. Okay, PAM, I did not develop it myself. It was developed by J.P. Pollock with Jerry Gay, part of his PhD thesis in information sciences at Cornell many years ago. It is actually validated. If you're going to ask people about affect or mood, you don't have to ask them a 9-point text-based question. He took these images. Think about this. I'm not just telling you about this because you might do some survey thing and ask people about mood. But think about translating what you want to ask people into a visual form. He took a whole bunch of images off of Flickr. He sort of it was before, he didn't use Mechanical Turk, but he got a bunch of people to rate those images as to what affect they represented. And now he has this repository of images, and they are displayed according to 2 dimensions of affect. Positive, negative, high and low energy. He didn't discover that. He took what the psychologist had already validated, and he's looking for an alternative measure. And now this comes up. It's not always the same images. They're always organized this way, right? But instead of the bull, you'll see something else, and you tap on the one that represents your mood. And he validated it against the standardized text-based ways, but this takes a second or less, and it's much, less. It's much less user burden. We went and riffed on that, and we do this for activities of daily living. So instead of asking text-based questions about activities of daily living, which is a measure of person's function, how long can they live alone? Are they having cognitive decline? Is that lower back pain thing helping them? It's not just about walking and things that are easy to measure. Are people able to do their activities of daily living? That's an established thing that we just went with that and said, okay, so instead of having these text-based things, and instead of asking this long list of standardized questions that you always ask, which people desensitize to, first of all, make it visual. Second of all, make it personal. So we have a full assessment. This is for lower back pain. We went and looked at what do people ask about for lower back pain, clinicians, and what do they talk about on patient fora. And you ask the person, and this is actually, the design of this is basically sort of inspired almost, Tinder-like, right? What is difficult for you on a difficult day? That becomes, and then you just sort of swipe left, right. This is difficult for me, this is not difficult for me. So what, bending over a sink to wash your face is difficult for some people, and this movement is what's hard. And then your inventory of your spot assessment, whether it's daily or at the end of a week, are your set of images, and you tap those that were difficult that week. So this, and people are using this in other contexts, and you can make it highly specialized. It's much faster, and it's personalized. So very low tech, but an alternative way of doing some kinds of self-report where you want people to do self-report from a particular inventory on a regular basis. And we have some correspondence with the standardized measure of lower back pain questions. This isn't very satisfying because that standardized measure is pretty crappy, but you have to do this if you're doing anything in health. Okay. I talked about location, activity, visual self-report, the Alexa stuff, and now just, more broadly, these other digital traces. We got to this because we talked about, went off on the tangent about takeout. this is just a visualization of that. This is a mock-up. This is not real data yet, right? From search and location in the context of IBD, for example. That's just, why is there a reason we might see data in these things? And so we're just starting an initial participatory design thing with some people in lupus. So we'll take a couple of people who want to be basically collaborators, and we'll get their takeout data. We'll do some filtering and summarization, and be able to talk to them about, was this a time of flare? They'll get their clinical record, and we'll do this in a couple of different conditions initially, which is to try to understand what is the right level of just simple analysis, filtering, and such that you need to do over this time series. Do we see signal there that corresponds to their clinical record, both formal as well as self-reported? And we're building a pipeline to do this. One of the things about this pipeline is that these data that we're using initially are all in Google. Now, we might have concerns about Google knowing as much as it does, but one thing about Google is that they are really good about security. They have so much to lose and so much money to spend on the problem, right? So we want, in doing this work, I have been made nervous by my security colleagues in saying through that IRB, we're going to take out that data and ask them to store it on their laptop or store it on our server. So we're trying to build a pipeline where the data sits in their Google Drive, like it sits in Google Cloud. So, in some sense, this, I don't like that there's one entity, right, that knows that much better, but this is stuff they know already. And from a security perspective, you can't do better than that. So we're the principle of trying to keep the data near its source, move the computation near its source, is something we used to do in sensor networks because we were worried about battery, but it makes even more sense with respect to privacy and security. In all these cases where we are sort of now is that the data streams are not so hard to get. It's pretty amazing, right, these data streams we can get. What isn't so clear is what we should do with them. Well, at the mid-level we know. We don't care about the triaxial accelerometer. We know how to do step count or minutes of active time versus sedentary. Easy to do, it's not that it's trivial. There were some papers that had to be written by various people of how do you figure out hours out of the house? How do you figure out house? Where is home? Right? Do you do that automatically? Do you ask the person to tell you? There's stuff to do there, but that's pretty much not so hard to do. Where the work needs to be done now, not the academic work, just the hard work of getting some small populations and doing it, is how do I take this, right? It's on face value. This is relevant to rheumatoid arthritis, MS, migraines, depression, IBD, and I can mention another, half a dozen things. These same data streams, because this is how we live our lives, are relevant to all of them. But how you should really interpret it for somebody in terms of, is there some way to get that detection of the flare of rheumatoid arthritis early? Really important, because every time you have a flare, there's joint damage. That joint damage is irreversible. You want to catch flares early. IBD, you want to catch flares early because people can get tremendously sick, and lots of these things, there are secondary effects, organ damage, and things. You need to catch them early. Can we begin to detect things that help people to identify their triggers and others? But the way in which you're going to use these signals is different for depression than for MS and for IBD. And right now, we need to go and validate how to use initial versions of what we call these digital biomarkers in these different conditions. And it is not sexy work. It is not academically interesting to lots of scientists. It is interesting to health scientists. They're just have been really slow. They don't really get modularity, and that we can do a bunch of this stuff and reuse it. So I was getting very frustrated and impatient with the world. And do I have to stop right now, or I can go a little more?
Keep going.
Okay. So, in March of 2015, I was as surprised as everybody else, even though I sort of thought of myself as being in this space, to wake up and find out about ResearchKit being announced by Apple and Sage Bionetworks. And, you know, I tell these stories in part because I just think they're, I learned something from the process, so maybe you can too. I was really annoyed. For 24 hours, I was very annoyed. I just couldn't believe in all kinds of, in just a petty way. Like, how is it that nobody told me? And also, iPhones, you know, that you're going to do medical research on people with iPhones and not with Android. Anyway, there was a postdoc at Cornell Tech at the time, and he said to me, Deborah, in 24 hours, everybody knew what we do. Like, get over it. And he was absolutely right. So I jumped onto this bandwagon because truthfully, all that we needed in this space was a bandwagon, that the clinicians would start doing things in a more modular way and not having every individual go and decide they want to do their app and find some software developer to do their app, and it was all going nowhere very, very slowly. I think it's something like 80% of all clinicians use iPhones. So they just don't consider anything else being relevant except for iPhones. So, but it's all fine. Apple invested a lot in this, and they put it on the stage, and they said it really loudly, and some of the studies are really awesome, and are really indicative of the kinds of things we could do. So my two favorite are the Empower study for Parkinson's. Empower took, same idea, took a clinical measure that is already used, a tapping test, that when you go into the clinician's office, not diagnostic, but, you know, to see how you're doing. Are your meds actually, you know, helping to reduce your symptoms? They took a tapping test, and they used the touch screen. And they did something else really important, I think very important for us academics, maybe even more important for computer scientists in the room. They didn't go and say, we're going to measure tapping while someone's typing and texting and doing other things. And we'll just do it ambient, they don't need to do anything, we'll get it all the time. They created active tasks. Once a day or a few times a day to try to see the difference between morning and evening, closer to medication time, after the meds have worn off, an active task comes up, and for a little bit, you know, a few seconds, you do the tapping test. Such an easier problem, as opposed to trying to tell amidst all the noise of the constant typing. The same for steps. Instead of measuring step counts in the background, they have somebody walk for 20 steps with the phone in a certain hand. It's not all the time, but this notion of active tasks makes so much sense as a way to get started. Ultimately, yes, there'll be great classifiers that'll pull it out even when you're not using it. So all these studies, first of all, have a really nice form of consent designed by John Wilbanks. He modernized, made it more visual. If you use nothing from ResearchKit, I would go and steal their consent process. They have these standard surveys, active tasks, and some passive. My other, it came out a little bit later, but the Duke Autism Research app is brilliant. So there's a standardized assessment for trying to tell if if a young child might be on the spectrum. And it's to show them some interaction, and they have canned videos with some small number of them with some social interactions, and they look at the child's response. And people are trained to observe the child in response to this stimulus. They put the video on the phone. The child sits in the lap. The camera records the facial response, the timing, and the nature of it in exact timing synchronization with the video. Just incredible. Incredible in the terms of like, okay, that's very powerful. There's some conversations I'm trying to get them to have with folks from the World Health Organization who are interested in identifying stunting in young children faster. You can imagine it being applied in that context as well, where you just can't get these trained individuals to do these kinds of assessments. Okay, so one second. So what's powerful about ResearchKit, and we developed the Android equivalent. So was asking around Google, okay, you know, don't we need an Android equivalent? For whatever reasons. But RWJ came up and said, okay, you know, give you some money, we just got a software development house, let's put together Research Stack, because of course RWJ doesn't want medical research only being done on people who can afford iPhones. What's exciting about these these frameworks is that they can be and are being these evidence engines. So you have to go and validate to see, does this actually work to measure? Does it correspond with traditional measures, both in Parkinson's and in autism and in the dozens of other studies that are being done? We're doing one on impulsivity that Fred Munch from Northwell initiated, and we both have the standardized measures, clinically validated measures. You go in and measure. You have go, no-go tests and balloon tests, delayed discounting tests, things like that. We just put them on mobile as an active task, no-brainer. And what we're exploring also is whether there's something, I will come to your question, or whether there's something in a passive measure or in a measure that is during texting. There has been anecdotal observation by psychologists that for people when their impulsivity is not as well managed, do a kind of pressured communication. So, you know, in bipolar, there's a notion of pressured speech. When people are having manic episodes, they do pressured speech. Yes, it's relative to your baseline. I always talk this way. And pressured communication is a similar idea, but when you get these repeated texts, one right after another, and then this, and then this, and then this, and then this, and everybody does that. Most people do that in some normal sense of some intensive situation, but there's been anecdotal evidence that this kind of rapid messaging is a little bit of a signal around impulsivity, so that's something we're exploring, both in by just getting information from the screen accelerometer without actually looking at contents of communication. You had a question.
Yeah. I was very obliquely involved in the Autism Beyond app. And there were 40 people, I think I counted at one point, that were actually engineering that.
Yeah.
Like all this stuff, my question is, all this stuff is so cool, like, is it ever going to scale to the point where like young folks, or like you have to have a team, you have to have a lab, how much money?
It depends there's a bunch of stuff that's just easy to do.
Yeah.
If you're using the same kind of components that other people have been using, it's really straightforward. If you guys are in here doing the kind of whatever, or Python, whatever kind of stuff you're doing, done some, HTML hacking, it is doable. Now, if you want to do something like what they did at Duke, where they're using, there's a lot of computer vision underneath it, right? A lot of things, but now they've done it. Okay? And that's a little bit more work, but to reuse that stimulus response thing, the combination of the video and the camera, it depends how sophisticated it is, but more sort of reusing existing components, that's what's good about the framework. It isn't that difficult.
And where would we find like code or examples, or like are there sites
in
that
GitHub.
Or just all
Yeah, so Sage Bionetworks continues to manage that, and as the community has grown to be both Research Stack and Research Kit, it's all open source. So it's pretty crazy that Apple did this open source project. That was all thanks to Sage, and it's a really interesting project. So now I'm wrapping up. One of the things that came, that is bothering me in the last few months, in particular, is just I've been on this rant about we should get access to our personal data. We should get access to our personal data, right? We want these personal data APIs so we can get this data and use it for things. And but there are some ethical dilemmas here that are posed by these things. And in particular, this isn't a made-up story. I woke up from a nightmare a few months ago, March, because I had read this article on Stat. If any of you are interested in health, by the way, this is just a fantastic daily newsletter on it, about the fact that there's this bill going through Congress that we're not protected from GINA in terms of our genomic data if you got your genomic test done through a corporate wellness program, which a bunch of corporate wellness programs have offered as a perk. You can go to 23andMe and we subsidize whatever, but it turns out that if you did that, they have some legal right to get to that data. So that was in my head at the same time that we're doing this impulsivity stuff, and at the same time that this whole, you know, healthcare coverage thing is, you know, crumbling around us. And so this notion that this, so I woke up in this nightmare that our impulsivity was a little bit of a grandiose nightmare, that our impulsivity work, our classifier, this pressured communication thing, was being used to deny people health coverage. Because impulsivity isn't a great thing for when it comes to health outcomes. Alcoholism, smoking, other forms of addiction, overeating, it's not a great thing. So, I don't know, and then it just started me thinking about all the other contexts in which if I have access to that data, I can be asked for that data. Whether it's when I'm crossing a border, coming back into the country, whether it's a domineering, you know, spouse or parent. Started me thinking about, you know, do we really want people to vote by mail and from home? If you vote by mail and from home, your ballot is available for people to inspect. So I just needed to mention this because it's very much top of mind. I have no idea what to do about it. We're, you know, trying to build systems that might let you get access to some data, have it more denatured, not only to keep a third party from having access to it, but even maybe just to have plausible deniability on your side as well. So Helen Nissenbaum, fantastic researcher, is really helping us do some of this work of more systematic ways of trying to understand what are the small data threats in any things that we do. Where are we dribbling out data to third parties? You know, when you download an app that's called, you know, opioid addiction, you know, break my opioid addiction, right? The name of that app is visible to the Google Play Store, therefore visible to Google. So can we do much better in terms of building tools that let people know what they're leaking and to help them guide towards better practices? My colleague and postdoc, Michael, is supposedly listening, and so I would not be able to enter the office tomorrow if I left without mentioning a sort of a platform we're trying to do to make it easier for people to use these data streams, not just from the perspective of studies, but also make it easier for people to do them in the context of interventions. So have a lot of interest. I haven't had a postdoc in a long time. My postdoc is a behavioral scientist and economist, actually, recently from Technion. So we're trying to just address that problem of making it lower the barriers to entry to be able to do this kind of work, not just when people are outside the clinical setting, but when they're outside the standard lab setting, in which you know, so much work in the context of behavior has actually been done. So we're working. We have a few early guinea pigs in this context. I don't know if any of you know Inbal Nahum Sahani from University of Michigan. We're doing a stress project of hers, and we're really interested in other folks who would like to do some kind of an intervention using small data and using this kind of research kit style app. And we're using research kit just as the vector for even going and saying, go and give us your consent to bring down this takeout data, not bring it down, but to bring that takeout data, be able to do some analysis with it. So I see it, those mobile research studies are good for people who are mobile because they have mobile on them, even if all the data isn't coming, even if you're pulling data that's beyond their mobile phone. Done. Somebody had their hand up. Okay.
Quick question. So one of the things I love about your work is you're always kind of at the bleeding edge, like you're doing stuff that really pushes the limits of kind of what is possible. And one of the challenges I see bringing that into the social sciences is a lot of the data problems you mentioned. So, you know, it's not a random sample, the data is patchy, there's errors, all this stuff. So then, but then I was thinking, well, one area where I think would expect data quality standards to be really high is health also, and that's the area where you are working in. So I'm wondering, like, am I not thinking about, like, what is the way
That's why Research Factor is so important.
Yeah.
Because you have to validate. So first of all, it's not the raw data, it's the trend data, and it's pulling the right things out of the trend data that would actually be the right feedback for adjusting somebody's medication or deciding that what they're doing now is actually leading towards improvement. So and the only way to do that is by doing clinical trials, by doing studies with people. And so the original research kit thing, which is just we tell the world, we get up on stage, and everybody who's interested in Parkinson's goes and downloads it. I think it's exciting and important in one context of thing. But to establish these measures clinically, you also need the clinical data from those individuals. So it's not something as like episodic as even something like, flu trends or flu near you, right? And building those models where you have some other sources of data to validate with. That's this hard work. Hard and not particularly sexy, but doesn't take 3 years, right? Where you take a cohort of individuals, diagnosed, you have clinical records, right? And you look at the analysis you need to do over this time series to catch the right part of the trend.
Okay, so could I try to?
Yes.
So it's sort of, you're saying, don't think about the data and all the problems it has. Think about doing some kind of transformation on that data, which you could validate. Then once that validation has happened, then you're good to go and you can use it for all social science. I mean, your helper, but any kind of social science.
And that's really, if you think about, that's what happened with going from accelerometry to step count.
I see. Okay.
Right? That wasn't with no, actual study. We did activity classifier stuff before these existed on Symbian phones, right? And you would get people to both go out and walk and run and do these different things on a number of different people of different height, weights, and whatever, and you would build a classifier that did a reasonable job across those, and then you can do an ambient and blah blah blah. So yes, it's features, it's derived values from these data, and the question is, how should those be used, right? They're not going to be a digital biomarker until we show that actually it informs a clinical decision in the right direction and is actually helpful. And yes, then you can go and use it. This is a reasonable indicator of somebody's being active or sedentary. It trends them correctly. You can safely go out and use these things. You can safely go out and use location, because the mapping to location, while yes, we all know not just GPS, but the location services are much better than they used to be, because it's not just GPS anymore. It's using all kinds of wireless, and it does a pretty good job. It's not perfect at all times, but for most of what we need, we don't need it to be perfect at all times. Yes?
So, the other way, in the social sciences, we've been trying to integrate digital trace data is like, we'll do a survey like the American National Election Study, and then at the end, we'll have a little app that has an authentication data, like say pull some Facebook data or something like that.
Yes. Yeah, which is like the takeout.
Is that a really good idea or a really bad idea on a number of, so like, I get that data's dirty, but I still see like tremendous value in it.
Yeah.
But what about, all these ethical things you've already, I can imagine like having someone's search history linked to their, their zip code, but it's just like, so do you have any, because I'm going to go to the American National Election Study organizers right now. And
yes.
I'm like after this talk, like I'm that excited about it. So, but is that a really bad idea?
Bad in an ethical sense, or bad in a? So
yeah,
tell me.
I guess ethical. Yeah, I guess.
So tell me exactly one more time.
So like at the end of the survey, it's an in-person survey, and
yeah.
they have like an iPad at the end that says, "Are you willing to share your Google data with us?" After you've answered all sorts of, did you vote for Trump? Did you vote for Clinton? Blah blah blah. Is it a bad idea?
What does share it with us? Is this IRB?
No, like so I would.
Without IRB, like not.
Oh no! It's certainly like all completely under IRB, and this would be, the data would never be publicly released. I would think.
Okay.
Oh, wait. Well, publicly released. What do you mean?
Well, like the Facebook data doesn't. It's like you can't just like go to the ANES page and then just read someone's feed. Like it would be some kind of restricted access. So like you'd have to, you get the data.
But it's big access. It's big. It's lots of people access it.
Hundreds of researchers.
So this stuff is impossible to de-identify.
Restricted. I don't know.
Yeah.
Yeah.
I mean, Location traces are impossible to de-identify.
Oh, no, I totally agree.
Like location trajectories, you cannot de-identify.
But like, what if it was like, you're just interested in like how many different neighborhoods someone visited, or like
sure.
how much time, because like a lot of stuff.
Yeah. So this derived thing, how many hours out of the house, or the diameter of your day, that is, you can de-identify.
Right, and that would be the kind of use case side of it.
Well, no, but then the question is, what do you pull out?
Yeah, of course, it's huge for trust.
So, no, but so if you define the features you want to pull out, then I would say having that feature set for that individual, like, I don't know, what would it, what it would be, the breadth or intensity of where they go for news or something like that, right? Or how big is, that might be something you pull out from their search terms.
The number of times they went to a conservative news site.
Exactly, right, and some feature, that might be the thing I pulled about, but to make available to, at broad scale from a public thing, the actual searches, yes, that makes me nervous, but you just have to say, okay, what should I pull out? And to do that, that little thing I described with the lupus patients, like initially I need to do this with some people who are effectively participating in the work, where there's no notion of hands-off, like they're participating, these are the features, that's how you, we have to decide what are the features that matter, that are the right things to pull out.
And then it sounds like in your workflow, you even do that on, like, from Google Drive or in Google Cloud?
We're doing it in Google Cloud.
So like you do all the analysis to pull out those features on Google Drive and Google Cloud.
Yeah, but then, and of course then you don't get to do collaborative stuff. Like you can't play the big data game and and then you could do things in between. Like you could do a focused research study where you do the bigger data game. You actually get all the detail. You build some better classifiers, and then that's what you use at a larger population scale. Yes.
So I have two questions. One is, what do you think is the kind of sort of model of work that, so say there's someone who's building an app, right? Like these health apps, and there are all these issues with sort of data privacy or so on and so forth. So is the model that there's an app that's released by that one team is in charge of developing, and then they use that for their own research, and then you have to sort of integrate into their research team in order to fully access the data? Or how do you envision this model going forward? Because at the moment I see only this model of research.
I don't know that there's one answer. It like depends on what kind of stuff. But what I think is exciting about ResearchKit and ResearchStack is that you don't have to use their study app. You can use their, tapping test. You don't have to, you don't have to use what we're doing with pressured communication. You can use it in some other way. You don't have to use that, join the autism group. Okay, so there are two things. If you're interested in something that isn't that autism study, but to use some of these components, this is open source. They're there as modules, and if somebody introduces a capability, you can use it too.
But what if you're still interested in the autism?
Yes, it bugs me too. I do not know what to do about that.
That's what I see right now.
Yeah, you're absolutely right. So if I had been designing that world, they didn't talk to me. But they probably, I'm not good at marketing. They won, they got it done because the way to get it done is you go to a group that's the best group, and you give them much funding, you get the right thing to happen, and you get that. But now what should happen is a good question. You can go and do your own. You can use the autism app. You can use a variant on the autism app. Is it open? It's all open. You can use a variant on the autism app and do it in your cohort. But it's not going to be the Duke autism study. And you probably should go and tell them that you're reusing it and give them tons and tons of credit. But they are doing it with the Duke autism study is their study.
So they don't release the data?
Okay. I'm so glad you asked me that question. So, some studies release their data in a de-identified form, and some don't. What SAGE, I don't really know. What I inferred was like, why did SAGE do this? SAGE Bionetworks did this in order to inject the Trojan horse, a good Trojan horse, that the default is that de-identified data is shared. So an individual can a participant has to explicitly opt out of having their de-identified data shared. So many of the research studies, unless the researchers, intentionally, explicitly turn that off, there is de-identified data being shared. A year to the date after they launched the Empower study, they published data in Nature, which was they published what was found about this publicly available data source of the de-identified data from their participants. So one very good thing about these research studies is injected into it is you don't have to go to the researcher and ask them. For many of the research studies, not all, they didn't say this is the only way you could use it, but the default behavior is that for a research study, you can go, and if you show that you're an academic or researcher or something, you can get access to the de-identified data, which is what Sage Bionetworks is about and is a really great thing.
Can I sort of ask a separate question?
Yeah, nobody else has. They just want to go eat or finish their project.
Yeah. So I really like this idea of thinking of an individual as capable of producing big data, right? I mean,
I didn't say that, but
sorry,
okay.
but that's
I'm
the
glad
way
you like data.
one can think of it that way, right? Big, small data.
A lot of data.
Yeah, a lot. And I like the idea a lot, and I like the idea of sort of thinking about how we have just so much variation over our life courses or over our daily routines. But I'm just wondering, sort of, again, coming back to sort of the question of between and within, between and within individual variations. So say that we find that there's a lot of variability within individuals as well, but when we want to come back and we want to sort of make comments on between population or between individual population level comparisons, right? I mean, so I heard your response to Matt, and to me was, we look at trends and we take a sort of difference in difference approach there, which erases some of the problems with bias. But I wonder if, how can we explain the fact that people have so much variation in their individual, that there's so much individual level variation? How do we make sense of that?
I think this is still hard to do that kind of science with. I mean, even the clinical context in which I'm talking about it's very engineering.
Yeah.
I'm trying to give an objective, high temporal resolution feedback on whether this person is showing the effects of increased pain.
Yeah.
And it's in order to serve a particular clinical decision.
Yeah.
So it's not. That's what I have to show.
Right. So your outcomes. I mean, I guess you're not trying to explain population.
No, it's an engineering thing.
No, but also then, so is there a way then? So the first thing that comes to mind is
I told you I wasn't a computational scientist. No,
but like, where do you think genetics plays a role in this, right? So like one of the things that one could say is that individuals are different, and one is that we sort of have information on their genetic history. And then we sort of have that as a way to
as a baseline in some context. Absolutely, this stuff will come together.
Yeah.
And it's not, it's and what's the balance, between those different components and how we put them together is an even bigger question. And I'm just trying to do this easier thing first, which is to say, this is what clinicians already know matters. They're not currently able to measure it other than in a clinical setting and without retrospective bias, retrospective recall bias. Oh, well, actually they could. So I'm just solving a much easier problem. I hope that through that process, we'll get enough data, access to enough data that we can begin to do big N versions of those things. But that somebody else will do, and there's plenty of utility. I'm not doing it just for that purpose. There's utility to be had in better care of individuals by doing this. But it's an easier problem. Yes?
So I think a lot about nutrition wasn't shown in this, and some of these apps don't do nutrition well. I've seen some things where they take pictures from Instagram.
Yeah.
Deserts. am I gonna be able to take a picture of like my plate and be able to estimate how many calories I'm ingesting?
So I can, thank you for calling me out on that because, look, nutrition is the thing. We started this conversation about, pizza, that he thinks it's just fine to talk about serving people pizza as the thing. I mean, it's just, to do anything in health and not try to do something about food is just like some intellectual, ethical fraud, right? It's really our food system more than anything else, but it's so hard to get information about what people eat. So we don't do it because it's so hard. Okay, but the computer vision and the amount of photos that people have taken of food, even in the decade, so in the first thing I ever did related to health, my first NIH meeting, I think it was 2006, I had been having people use phones to take pictures of like garbage cans or environmental things because I was still, my application modality was environmental ecology, environmental science. So I went to an NIH meeting and they were talking about monitoring about dietary information. First of all, I did not know, just out of stupidity and naivete, that all the research to that point, when people would report that eating X increases or reduces your chances of getting Y, that all of that data was from self-report. Things like, dietary inventories, 2-week inventories, how many times a week do you eat broccoli? So I was just appalled that that was actually the case. There are big public health studies where they study, at an inventory level in markets, supermarkets and what's going on in the food provision. They can measure they know that there's more olive oil consumed, right, in Greece than in New Jersey, right? So, but most of the individual studies are based on people's self-report, retrospective self-report. So the first thing I did was something called Diet Sense. It was on a Nokia phone, that's what there was, outward facing around somebody's neck, and we just programmed it to take pictures every 10 seconds. So that instead of, not that you would wear it all the time, but so that if you're doing trying to understand food allergies or whatever it is, you're doing a week-long, 2-week-long inventory, this would be your source of the inventory. Anyway, I ended up hating the project. I rarely ever actually talk about it. But it was all, at that time, there weren't lots of food images. People didn't have smartphones. But now, computer vision is in a completely different state. And it's really good at this problem of even identifying food on a plate and other things. Yeah, computer vision will continue to get better and better, but with all this obsession with people taking pictures of their meals, of course, only the ones they want to advertise, not the ones they're ashamed of. The computer vision is very good. The behavioral notion of thinking you're actually capturing what people are eating, 24/7 what they fully eat. You don't get a food inventory by intentionally taking pictures, but maybe you can get people to engage in the act of, high school kids taking pictures of their snacks during the day, right? There are things you can do or get, capture dinner. But the computer vision side, that has, just evolved tremendously. Yeah.
I have a question about the first part of your talk about your work on internet architecture.
Yeah.
And I work at a Center for International Security, and we talk a lot about cybersecurity. And
yeah.
So I'm just curious if you could get into a time machine and go back and redesign the entire internet, given what we know now.
I know, but we don't know. Yeah. So does everyone else know what you're referring to? So security wasn't built into the base of the internet, right? Even and actually, my PhD thesis was on the topic of adding some level of access control authentication to packets. Okay. I do not think, though, see, I told you so, if we done, not at all, because probably the internet wouldn't have grown to be what it was. I also thought that maybe we should have that the problem was that packets were free, and, tragedy of the commons, free isn't like anything that would push back against, nobody caring. There are things that could be done security, there are things that could be done by not having everything be entirely free. But had we done any of those things, I don't know what state the internet would be in, or the web, or anything else. So, but that's what I said in response to that question 10 or 15 years ago. And now, it's, I think the questions are not just that, the questions are also the fact that we didn't stick, the industry didn't stick with an internet architecture. We have, walled gardens platforms, right? At the router level, yeah, right? At the, but everything that's up above HTTP and, Facebook is a closed platform. And so we have a level of, and we developed a whole industry where everything is winner take all, and I worry about more. I'm not going to argue with you which is more important, but I worry about the political, social, world effects of that more than I do the fact that security wasn't built into the lower levels of the internet. And now with people doing all kinds of stuff, look, you're at the institution that's one of the main institutions that started software-defined networking, Jen Rexford, and a lot of virtual stuff that gets built on top. People are doing things on the security side of it. And maybe it's inevitable that we would end up, that it's just the nature of the economics of the situation, that we would end up in a situation where there's just so much economy of scale. Anyway. Yes?
I'm wondering about sort of this range of how passive the data collection is here, right? Some is more passive than others.
Yeah.
And I wonder if some of the sort of value of your operation is almost to change people's behavior, the Heisenberg uncertainty principle. If I had my doctor following me around all day, I wouldn't eat as much pizza.
Yep.
Right?
Yep. So the intervention and reactivity, first of all, you have to, of course, account for reactivity. But in certain contexts, when the reactivity is in the direction that is a positive thing from the health perspective, that's great. I don't think that this is a great way to intervene for people who, for example, have a tendency or history of anorexia, right? There are other forms in which that intervention to study it could be really far too high of a risk. So, but for many of the conditions, it probably goes in an okay direction. It is what you're trying to serve in the end, but if you're trying to do social science, it's a problem. And then, it's that things being entirely passive or not even knowing if it's measuring or not. I don't worry about that because I'm an engineer. But if I was being really a scientist there, you have to worry about it much more. Last question.
So I was wondering about how uneven our outcomes can be sometimes. So today I ate a ton, so I'm probably not going to eat that much tomorrow. Mm-hmm. And I'm wondering about the idea of with all these apps trying to make people be consistent, right? You need to be consistently happy, or you need consistently eat the same thing. Are these actually good for people to be consistent in that way?
I have no idea. My gut response is the same. Is similar to yours, right? And I think it's a very good question to ask, which is what is this somehow, this focus, for example, on increased physical activity, right? People have done the studies, there's been long enough that people have done the studies that if you're trying to address weight loss, and you do it by introducing physical activity measures, and you don't address the other balance in the equation, some people gain weight when they start to have a measure of their increased activity because they reward themselves for walking more. So, this stuff needs to be done. Carefully. And now there are some people who believe, and they even think there's some science behind unevenness is good, right? Fasting days and all that stuff. I'm not an expert. I have no idea. Maybe we could actually learn if we did systematic studies. But the notion that there's just something that is the right behavior and everyone should try to do it all the time, I agree with you. Like being happy. Overrated.
All right, let's all thank you again.